Now we're going to factor out GCFs. So take a minute, do the warm-up. You're going to be doing some distribution like you did in Chapter 7. Number 1, when you distributed the 2, you should have had 2w plus 2. Number 2, when you distribute 3x times 4x, you have 12x squared. 3x times negative 3 is negative 9x. Now let's distribute our 2a squared times 3b. 2 times 3 is 6a squared b. 2 times negative 4 is negative 8. A squared times a is negative 8a cubed. Now we're going to be doing the reverse. You're going to get something that looks like your answer, and your answer will be something like the top. So let's just take a second and look at that. See, you can see that this looks like the answers to our warm-ups, and we're going to be doing the reverse. When you are doing that, it's almost like undoing the distribution. And I do this in 3 steps. The first thing is to find the GCF of all the terms. In this case, we have 2. So our GCF of 4x squared and 3x. Well, the GCF number is, the biggest number that they have in common is 1. And the greatest x variable they have in common is just x. So that was the first step. The second step is to divide, because it's essentially you're taking it out. Divide all terms by the GCF. Your final answer, the way that you write your answer, is going to be GCF times, and I call them your leftovers. That's after you divide. So leftovers are after division. So what I mean by that is my GCF is 1x, so I'm going to put my x out here, times whatever I get left over. So this is my GCF, and this will be my leftovers. So let's divide it out to see what we have left over. So divide by x, divide by x. 4x squared divided by x is 4x. 3x divided by x, the x's cancel, plus 3. Step 3 is to check by distribution. I also look in my leftovers and see what is the GCF of my leftovers. If your GCF in here is 1, so your GCF of your leftovers has to equal 1. If it doesn't equal 1, then you didn't take the greatest number out. 4x and 3, yes, it's 1. So to do your check, you would just do x times 4x plus 3 and distribute in. X times 4x is 4x squared. X times 3 is plus 3x. Check. You know that you are good. Let's try another one. Factor 10y cubed plus 20y squared minus 5y. Let's first see what our GCF is. 10, 20, and negative 5, the GCF here is going to be 5, and they have 1y as their greatest. So again, I'm going to take my GCF 5y times my leftovers. I always do this first. I always write GCF times my leftovers so that I remember, and now I take it out. When you're taking it out, it's essentially like you're pulling 5y out of each one of them. And when you pull 5y out of each one of them, you're dividing it out and you're putting it out front because you multiply it back in and they're inverses of each other. 10 divided by 5, remember this is like chapter 7, 10 divided by 5 is 2, y cubed divided by y, 3 minus 1 is y squared, 20 divided by 5 is plus 4, y squared divided by y is just y, negative 5 divided by negative 5 is negative 1, y over y cancels. And then check it out. Do your distribution back in. 5y times 2y squared plus 4y minus 1. Let's make sure that it works. 5y times 2y squared, 10y cubed. 5y times 4y plus positive 20y squared. 5y times negative 1 is negative 5y. Yep, so we know we got it correct. Always, always, always check. This one's a little different because if your first term is negative, you have to factor out the negative. So in this case, my GCF, I know because my first term, well, first of all, I'm going to go ahead and I'm going to put it in standard form. But in standard form, it would be negative 12x squared minus 14x. This is my standard form. Remember from chapter 7, where you have to have your biggest exponent, then your next. But I still have a negative as my first term. So it's negative. Right away, I know it's negative. What's the GCF of 12 and 14? Well, the GCF there is 2. So negative 2, the biggest x is x. So my answer is going to be negative 2x times whatever I get left over. Divide by negative 2x, divide by negative 2x. Negative 12 divided by negative 2 is positive 6. X squared divided by x is x. Negative 14 divided by negative 2 is positive 7, and my x's cancel. When I look at my leftovers, is my GCF of 6 and 7 1? Well, it sure is. So then you can go ahead and you can check it again. Negative 2x, 6x plus 7. Negative 2 times positive 6 is negative 12x squared. Negative 2x times positive 7 is minus 14x. That's what we wanted. That's what we got. Now we can box our answer. For number 4, let's find our GCF. So this is number 4. Our GCF, there's 3 terms, 8, 4, 16. The GCF number is 4, and it's already in standard form, and it's not negative. X cubed, x squared, and x is just x. So I'm going to take my GCF, 4x, times my leftovers. So let's find our leftovers. Divide by 4x, divide by 4x, and divide by 4x. 8 divided by 4 is 2. X cubed divided by x is x squared. Negative 4 divided by 4 is negative 1. X squared divided by x is x. Negative 16 divided by 4 is negative 4. And the better way to write this would be 4x times the quantity 2x squared minus x minus 4. There you have your answer. You can do a quick check. 4x times 2x squared is 8x cubed. 4x times negative 1 is negative 4x squared. 4x times negative 4 is negative 16x, which is what we had at the beginning. So there we checked it all out. Number 5, 3x squared plus 3x cubed plus 2x squared minus 10. Your GCF number is 1, and 10 doesn't have an x, so there's no x's in common. So if your GCF is 1, oh, this is very nice. You can't factor further. You're done. Because if your GCF is 1, when you divide by 1, it doesn't end up being the exact same. Now we're going to factor out a common binomial. If you look here, you have multiplication 5 times x plus 2 plus 3x times x plus 2. So here your GCF, if we're looking at the factors, if I were to make a factor tree of this first term, I would say that 5 times x plus 2, if I were to write it out as a factor tree, would be 5 times x plus 2. My second term, 3x times x plus 2, if I were to write it out as a factor tree, I'd have 3x times x plus 2. Notice x plus 2 is a common factor of both. So when I notice that they have a common binomial, that x plus 2 is my GCF. So I'll have x plus 2 times, this was still my GCF, now I need to get my leftovers. So if I divide out in parentheses x plus 2, divide out in parentheses x plus 2, Notice x plus 2 over x plus 2, they cancel, and you're left with 5. X plus 2 plus x plus 2 cancels, and you're left with plus 3x. This looks like something from chapter 7 again. So now, whenever you check it, you just have to distribute twice. X plus 2 times 5 plus 3x. So let's check it. X plus times 5 is 5x. X times 3x is plus 3x squared. 2 times 5 is plus 10. And 2 times 3x is plus 6x. When you combine it and put it in standard form, you get 3x squared plus 5x and 6x is 11x plus 10. But you might be wondering, that doesn't look like the original. Your original, though, is not simplified. If you took your original, 5 times x plus 2 plus 3x times x plus 2, let's see what happens if I simplify it. I get 5x plus 10 plus 3x squared plus 6x, which simplifies again to 3x squared plus 6x plus 5x is plus 11x plus 10. So you can see when they're simplified, they did in fact work and check out. One more, if you look and see, you have a common binomial. But in front of this one, there's the number 1. So our GCF equals t plus 4. So we'll go ahead and we will factor out our t squared plus 4. So my GCF, t squared plus 4 times my leftovers. If I divide by t squared plus 4, divide by t squared plus 4, they cancel, and you can literally see negative t plus 1. Now, for time's sake, we're not going to go through the check on that one, but it does, in fact, work. This last one, again, I want you to try. This is your number 2 on the back. And this here, again, we have a 1. Anytime I don't see a coefficient in front of my second binomial, write the number 1. So my GCF equals b squared plus 1. And I'm going to go ahead and put, so we're going to do the same thing, our GCF times our leftovers. So we have b squared plus 1 times whatever we get when we divide out. B squared plus 1, divide by b squared plus 1. They cancel, negative 2b. They cancel, plus 1. There you have it, your final answer. Ooh, this is z squared plus 7. This is 2z cubed plus 1. They're not the same. They're different. Different binomials. So you can't factor further. And you are done. The same thing here, 3x times y plus 4 minus 2yx plus 4. Y and x are different. You can't factor any further. We have one more example. It's factor by grouping. So literally what you do is you first put parentheses around the first 2 terms. 1, 2. Then you factor out the GCF. So I did the first 2, and then I also did these 2. Let's find our GCF of each group and do the same thing. So our GCF here would be 2h cubed. The GCF of my second group would be 12 and 8, 4. So let's factor out our GCF. If I factor out, so I get, let me rewrite this so you have a little bit more room. 6h to the 4th minus 4h cubed. We grouped that. And then we grouped our plus 12h minus 8. And this was a positive 4 I'm going to factor out. So for here, I'm going to divide out
2h cubed